the Sun, a celestial marvel that has fascinated humanity for millennia. A gigantic ball of burning gas, composed primarily of hydrogen and helium, undergoing nuclear fusion at its core. This colossal furnace, raging millions of miles away, generates an immense amount of energy, which radiates out into space. It's hard to believe something so far away plays such a crucial role in our existence. Yet it is the very reason life thrives on our planet. Without the Sun, our planet would be a lifeless, frozen wasteland. The warmth and light it provides are essential for sustaining life. Imagine Earth, shrouded in darkness, with no warmth to sustain life. The oceans would freeze, the atmosphere would collapse, and all forms of life would perish. That's the reality without our Sun, a cold, desolate planet drifting aimlessly through the cosmos. It's the single most important celestial object for us. Its gravitational pull keeps our planet in orbit, ensuring a stable environment where life can flourish. This massive star, the closest one to our planet, is the source of all life and energy on Earth. Its rays drive photosynthesis, the process that fuels the food chain. But the Sun is much more than just a source of light and warmth. It is a dynamic and ever-changing entity, with solar flares and storms that can impact our technology and climate. It's a fascinating celestial object with its own story to tell, a story of birth, life, and eventual death. Born from a cloud of gas and dust, it has been burning for over 4.5 billion years. Let's delve into the heart of our solar system and uncover the secrets of our very own star. From its fiery birth to its eventual demise, the Sun's journey is a testament to the incredible forces at work in our universe. The Sun isn't just our source of light, it's the boss of our cosmic neighborhood, the solar system. Everything revolves around it. Planets, moons, asteroids, comets, they all dance to the tune of the Sun's gravity. It's like the conductor of a grand orchestra, keeping everything in sync. The Sun holds our solar system together. Its immense gravity keeps the planets in their orbits, preventing them from flying off into the vast emptiness of space. Like a giant magnet, it keeps everything in check. But don't let this image of a static system fool you. It's anything but still. The planets are constantly moving, orbiting the Sun at incredible speeds, but the Sun's gravity is relentless, holding them in their paths and sculpting the very fabric of our solar system. What is the Sun made of? This question has fascinated humanity for centuries, and the answer is both simple and complex. At its core, the Sun is a massive, glowing sphere of hot gases, primarily composed of hydrogen and helium. These two elements are the lightest and most abundant in the universe, making up about 98% of the Sun's mass. It's mainly hydrogen and helium, but there are also trace amounts of other elements like oxygen, carbon, neon, and iron. These elements, though present in much smaller quantities, play significant roles in the Sun's complex processes. The two lightest elements in the universe, hydrogen and helium, are the primary building blocks of the Sun. Hydrogen atoms, under immense pressure and heat, undergo a process known as nuclear fusion. This fusion process is the heart of the Sun's energy production. Think of these elements as the Sun's fuel, constantly churning and reacting within its core. The core is the powerhouse of the Sun, where temperatures soar to about 15 million degrees Celsius. Here, hydrogen atoms collide and fuse to form helium, releasing vast amounts of energy in the process. This process, called nuclear fusion, is what powers the Sun. It's the same process that powers hydrogen bombs, but on a much grander and more controlled scale. The energy produced in the core slowly makes its way to the Sun's surface, taking thousands of years to travel through the dense layers of the Sun. Deep within the Sun's core, under immense pressure and heat, hydrogen atoms fuse together to form helium. This fusion process releases a tremendous amount of energy, which radiates outwards from the Sun's core, eventually reaching us here on Earth. This energy is what we perceive as sunlight and feel as warmth. This fusion process releases a tremendous amount of energy, which radiates outwards from the Sun's core, eventually reaching us here on Earth. The journey of this energy is a fascinating one, as it travels through various layers of the Sun, each with its own unique properties and functions. But the Sun is not just a homogeneous ball of gas, it has a complex structure with multiple layers, each playing a crucial role in its overall function. The core, where nuclear fusion occurs, is surrounded by the radiative zone, where energy is transferred outward by radiation. It has layers, each with its own unique characteristics. There's the core, the radiative zone, the convective zone, where energy is transferred by convection currents, and the photosphere, the visible surface of the sun that we see from Earth. The photosphere, the layer we see, is where sunspots and solar flares occur. These phenomena are caused by the sun's magnetic activity and can have significant effects on space weather and communication systems on Earth. And the atmosphere, which includes the chromosphere and the corona, extends far beyond the visible surface. The corona, visible during a solar eclipse, is a hot, tenuous outer layer that emits X-rays and ultraviolet radiation. Each layer plays a crucial role in the sun's life and energy production. Understanding these layers helps scientists predict solar activity and its impact on our planet. The sun, with its dynamic and complex structure, continues to be a source of wonder and discovery. Section 4, feeling the heat, the sun's temperature. Hold on tight, because the sun's temperature is mind-boggling. At its core, it's a scorching 15 million degrees Celsius. That's hotter than any furnace on Earth, hot enough to vaporize anything we know. This intense heat is a result of the nuclear fusion reactions happening within. But the sun's temperature isn't uniform. As we move from the core to the surface, it gradually decreases. The surface, called the photosphere, has a relatively cooler temperature of around 5,500 degrees Celsius. Still, that's hot enough to melt any known metal. And then there's the sun's atmosphere, which is even stranger. The outermost layer, the corona, is surprisingly much hotter than the surface, reaching millions of degrees Celsius. Scientists are still trying to understand this phenomenon. Section 5. The sun's energy, our daily dose of sunshine. The sun, our closest star, is a colossal ball of gas that has been burning for over 4.6 billion years. Its energy is the cornerstone of life on Earth, influencing everything from the climate to the very air we breathe. Every day the sun bathes us in its light and warmth. This daily dose of sunshine is not just a source of comfort and joy, it is essential for our well-being. Sunlight triggers the production of vitamin D in our skin, which is crucial for bone health and immune function. It also helps regulate our sleep-wake cycles, known as circadian rhythms, which affect our mood and energy levels. This energy, traveling millions of miles through space, is the engine driving life on our planet. The journey of sunlight begins at the core of the sun, where nuclear fusion reactions produce immense amounts of energy. This energy then travels through the layers of the sun, eventually reaching the surface and radiating out into space. It takes about 8 minutes and 20 seconds for sunlight to travel from the sun to Earth, covering a distance of approximately 93 million miles. It's hard to overstate the importance of this energy. Without it, Earth would be a frozen, lifeless rock drifting through space. The sun's energy is what makes our planet habitable, providing the warmth necessary for liquid water to exist and for life to thrive. It influences weather patterns, ocean currents, and even the geological processes that shape our planet's surface. It's what plants use to photosynthesize, producing the oxygen we breathe and the food we eat. Photosynthesis is the process by which plants convert sunlight into chemical energy, using it to transform carbon dioxide and water into glucose and oxygen. This not only sustains the plants themselves, but also forms the base of the food chain, supporting all other life forms on Earth. But the sun's energy doesn't just power life, it powers our planet. Humans have harnessed this energy in various ways, from ancient sun-worshipping rituals to modern solar-powered technology. Solar panels convert sunlight directly into electricity, providing a clean and renewable source of energy. Wind turbines, too, rely on the sun as it heats the Earth's surface unevenly, creating wind patterns that we can capture and convert into power. It drives our weather patterns, creates winds, and fuels the water cycle. The sun's energy causes water to evaporate from oceans, lakes, and rivers, forming clouds that eventually release their moisture as precipitation. This continuous cycle of evaporation, condensation, and precipitation is vital for replenishing freshwater resources and sustaining ecosystems around the globe. Without the sun's energy, our planet would be a very different place. Cold, dark, and lifeless. Imagine a world where the sun never rises, where temperatures plummet to uninhabitable levels. and where the vibrant colors of nature are replaced by a bleak, monochrome landscape. Life as we know it would cease to exist, and Earth would become a barren wasteland. The energy we receive from the sun is only a tiny fraction of what it actually emits. The sun releases an enormous amount of energy every second, but only a small portion of it reaches Earth. Despite this, the energy that does make it to our planet is more than enough to sustain all forms of life and drive the processes that keep our environment in balance. But even this small fraction is enough to sustain all life on Earth. From the tiniest microorganisms to the largest mammals, every living creature depends on the sun's energy in some way. In the depths of the ocean where sunlight cannot reach, life still relies on the energy that filters down from above, supporting complex ecosystems that thrive in the darkness. It's a humbling thought, realizing that our very existence depends on this distant star. The sun, a seemingly ordinary star in the vast expanse of the universe, is the lifeline of our planet. As we go about our daily lives, it's worth taking a moment to appreciate the incredible journey of sunlight and the profound impact it has on everything we hold dear.